So next question on beam is a beam ABCD having self weight 2 kilonewton per meter. See here the new thing is self weight, that is 2 kilonewton per meter, is subjected to additional load as shown in below figure. So this is the given figure. Find the support reactions at B and C. Okay, this is the given question. So here it is 5 kilonewton per meter. So now let us look into the diagram, that is the given beam. So here the length of the beam is, that is 2 plus 5 plus 2 plus 5, that is the overall length of the beam is 10 meter. Okay, then next at the left hand it is subjected to two horizontal forces. One is that is both are 5 kilo Newton. Okay, and from the point A they are separated at a distance of 0.8 meter and 0.4 meter. Then coming to the support B, here at the point B is supported by a hinge support or pin support. Okay, then next coming to this point C is supported by a roller support. Here rollers are there. Okay, so if one of the support is roller, then other must be the hinge or else the pin support. Okay, and next here nearer to the roller support, the span B to C is loaded by 5 kilonewton per meter, and that is UVL. And at the right hand side, okay, at the right hand the beam is subjected to a 10 kilonewton, and which is acting at an angle of 10 degree with the vertical axis. Okay, means it's not perfectly horizontal or perfectly vertical. Okay, to solve the problems I need all the things must be either perfectly vertical or perfectly horizontal. Means I have to resolve this one, okay, before proceeding to solve the question. And then next I have to convert this into a point load, because this is now UVL, and next here two horizontal forces are there. Okay, so I have to convert this into a either a perfectly vertical load or perfectly horizontal load, or else a moment. Okay, if it forms moment, then we shall convert that into a moment. Let us start from here. So here these are the two forces and which are equal in magnitude. Okay, these two forces are equal in magnitude. Okay, so I am drawing here as it is 5 kilonewton, and one more force is moving in this direction, it is 5 kilonewton, and which are separated at a distance of 1.2 meter. Okay, and which are separated with a distance of 1.2 meter. Okay, now so we know the definition of couple. Okay, couple constitutes with the help of two forces which are equal in magnitude and opposite in direction. Means these two forces can constitute a couple. Okay, so moment of a couple is equal to, we know moment of a couple is equal to magnitude of one of the force multiply with the perpendicular distance. Okay, so now here the magnitude is 5 kilonewton. See, magnitude of one of the forces. Okay, so it is 5 multiply with the perpendicular distance, that is 1.2 meter. So the moment here will be, it is 6 kilonewton meter. Okay, so this is the resolution of these two forces. Then next coming to this one. Okay, now I draw this much separately here. So it is like this. Okay, I am not including the support. So here it is like this. Okay, and it has spreaded over a distance of 2 meter. Okay, this load has spreaded over a distance of 2 meter. So from here to here it is 2 meter. Okay, so here it is 0 and here it is 5 kilo Newton. Now I have to convert this into a point load. Magnitude of point load. Okay, magnitude of point load for UVL is equal to WL by 2. Okay, so it is 5 multiplied with the length is 2 meter, 2 divided by 2, so it is 5 kilonewton. It is 5 kilonewton. The next question is where it will act. Okay, it acts at L by 3 from perpendicular side. Okay, and 2L by 3 from the apex. So let us find the distance of this force from the perpendicular side. Okay, that is L by 3 is equal to 2 by 3. So it is around 0.67. 2 by 3, it is around 0.67 meter. Okay, so now let us draw the free body diagram of this whole figure. Wherever the forces and supports are there I have to draw a dotted vertical line. Okay, next here this UVL is going to act somewhere here. Okay, so let us draw one more dotted line here. Then next it is A, it is B, it is C, it is D. Okay, so at the point C it's a roller support, so here it will have one reaction, that is RC. Okay, and then next here this B is supported by a hinge or else a pin. Okay, hinge or pin support. Okay, this type of supports will have two reactions. In case the horizontal reaction is absent, then this type of support will also have only one reaction. Okay, but now here this beam has been subjected to a inclined force. Okay, means it will have one horizontal reaction, because when I resolve this inclined one, it gives us two components, one along the vertical and the another along the horizontal. Okay, to resist that horizontal component there must exist one horizontal reaction. So here it is. So let us say it as By, and I am assuming the reaction in this direction, it is Bx. Okay, so these two forces have been reduced to a one moment. That moment is here, that is 6 kilonewton. So and its direction is in this direction. Okay, because this rotates in this direction. Okay, this rotates in this direction if this is the point of consideration. Okay, so I have drawn as it is, and its magnitude is 6 kilonewton meter. Okay, so this is over. Then next, there are no forces here from here to here, and from here to here there are no forces, and here one force is acting, that is the point load. Okay, so it is point load is one point load is acting here, and the magnitude of that point load is here it is. Okay, magnitude is 5 kilonewton. So here it is 5 kilonewton. Now where it is acting? It is acting at a distance of 0.67 from perpendicular. Okay, so for this one, perpendicular is at the point C. Okay, from C it is acting at a distance of 0.67. So from here to here it is 0.67. Okay, then next coming to this one, that is at the right hand. Here it is now inclined one. I am going to resolve this. So here it is 10 cos 10, and then next it is 10 sin 10. And here one more force is acting, that is self weight 2 kilonewton per meter. Okay, this we usually forget to take to consider in the solution of the problem. Okay, that we should not do. So here it is 2 kilonewton per meter. It's a self weight, means it acts over the whole span of the beam. Okay, whole span of the beam is from here to here. Its overall length is 10 meter. Okay, it is 2 kilonewton per meter, means it's a UDL. It is 2 kilonewton per meter. Its free body diagram is, it acts somewhere here, and its magnitude is WL, that is 2 multiplied with 10 is equal to 20 kilonewton, and this force acts at a distance of 5 meter from this end. Okay, this is end of the beam, and 5 meter from the other end of the beam. Same we have to draw here. So from this end I have to mark one point at 5 meter, and from this end also I have to mark one point that is at a distance of 5 meter. Okay, let us mark the point from this side. It is from here. From here it is acting somewhere, and the distance is 5 meter. This distance is 5 meter, and here the load is acting. Here this load is acting. Its magnitude is, now only we have calculated, its magnitude is 20 kilonewton. 20 kilonewton. This is the free body diagram. Here I have considered all the given forces as well as the self weight of the beam. Okay, if he gives in the question self weight of the beam is so and so, that time I have to consider the self weight of the beam also. If it is not given, then we can neglect that. Let's use the equilibrium equations. Those are summation of H is equal to 0, summation of V is equal to 0, summation of moment at any point is equal to 0. So use first one, summation of H is equal to 0. Here there are two horizontal forces. One is Bx moving towards the left hand side, and this 10 sin 10 moving towards the right hand side. So it becomes minus Bx plus 10 sin 10 is equal to 0. On solving we get Bx as, it is 10 sin 10, we get it as 1.736 kilonewton. Next use the second equilibrium equation, that is summation of V is equal to 0. Summation of V is equal to 0. Here it is By moving in the upward direction, it is By plus Rc moving in the upward direction, Rc is equal to 20 kilonewton moving in the downward direction. It is 20 plus 5 plus 10 cos 10. It becomes 20 plus 5 plus 10 cos 10. It is equal to 34.848. Call this as equation number 1. here it is By plus Rc. Now I have one more equilibrium equation, that is summation of moment at any point equal to 0. Let us take the moment from the point C. Let us take the moment at the point C. Means now I have to find the vertical distances of all the forces and reactions from the point C. So this is the point C. From here to here the perpendicular distance is known, that is 0.67. Then next, coming to this, from point C to 20 kilonewton I have to find the distance. If we look into the main figure, sorry, no need to go for the main figure. So here it is, from here to here it is 5 meter. Okay, it is acting, and this 20 kilonewton force is acting at a distance of 5 meter from the right end. Okay, that is here. Now I have to find the distance between this point C and the 20 kilonewton load. Okay, so from here to here it is known, it is 3 meter. It is 3 meter, and from here to here it is known, it is 5 meter. To find this one, what I have to do? I have to deduct this 3 from the 5 meter. So from here to here it is 2 meter. From here to here it is 2 meter. Then next, from the point C to B it is 5 meter. Okay, so this is a moment, there is only to find the perpendicular distance of that moment. I have to find the perpendicular distance of only horizontal and the vertical forces. Then next, coming to this right hand side portion, here it is one horizontal force is there, that is 10 sin 10, and that passes through the point C itself. So there is no need to find the perpendicular distance. The perpendicular distance is 0, because of that only it is the moment, because of that is 0. Then next, here one more vertical force is there, and its perpendicular distance is given, that is 3 meter. Now find the moment. So this is the point of consideration, that is point C is the point of consideration. Starting from this end, it is anti-clockwise, so it is -6. Then next, coming to this one, it is clockwise, so it is plus By, and the perpendicular distance is 5 meter, it is 5. Then next, coming to this one, this is the point of consideration, it is now anti-clockwise, so it is 20 into the perpendicular distance is 2 meter, so it is 2. Then next, coming to this one, it is again -5 into 0.67. Next, coming to this one, it is plus 10 cos 10 multiply with the perpendicular distance. The perpendicular distance is 3 meter, it is 3 equal to 0. On solving the calculator, we get it as 3.96. So By is equal to 3.96 kilonewton. Now on substituting this value in the equation 1, we get Rc. Let us substitute that one. We get, that is 3.96 plus Rc is equal to 34.848. Rc is equal to 34.848 minus 3.96. It is 34.848 minus 3.96, 30.88. We get Rc as 30.88 kilonewton, that is in the upward direction. So this is the solution. Okay, the problems are very easy, but the main thing is we should know how to draw the free body diagram, and whatever he has given in the question, all that we have to consider for solving. Okay, if we miss the self weight, then our problem will become wrong. Okay. Oh.